Okay, here's a 2008 multiple choice BC. Currently, this is a non-calculator. Okay, and this is going to be number 1 through 30 minutes maybe, and then I'll upload it, and then we'll go on to the next group. Okay, so at time t is greater than or equal to 0, a particle moving in the x-axis plane has a velocity vector given by, okay, so here's my velocity vector. It's interesting, it doesn't look highlighted. Okay, so this is t squared 5t. This is in vector form. What is the acceleration vector of the particle at t equals 3? So they want the acceleration at 3. Okay, so we're going to take the derivative. Okay, and even though this is free response, multiple choice, and this year the free response is the only thing they're going to have, it's still good to make sure that we have our notation here. It's good to have multiple choice so we can practice quicker on more topics. Let's see, this is a of 3, which would be 2 times 3, comma 5, which is 6, comma 5. Okay, so we're definitely going to want to show enough work. So that answer is B. Just as a little extra, we'll say what if. Okay, so what if they wanted the magnitude of the acceleration? Okay, that would be the square root of 6 squared plus 5 squared. Or what if they wanted the speed? So the speed is the absolute value of velocity, right, at 3. And then that would be at 3, we would have to find the velocity vector. So let me find the velocity vector. So the velocity vector would be 3 squared and then 5 times 3. So this would be 9, 15. And then I want the magnitude of it. So 9 squared plus 15 squared. And then I would figure that out. Okay. So these are both what ifs. So we're not really going to work those out. But just some information about these. If they did want total distance, I guess let's do one more. So what if they wanted total distance? Total distance is the square root. Right, it's the, in AB and BC, it's the absolute value of velocity, okay, from A to B. So velocity, absolute value of velocity when it's in BC format. You know what, I think they did take this off of the BC test. Would look like this, and then you would do, basically you would do t squared plus 5t squared, and then you would do the integral. Kind of looks like arc length. And then you would pick your A and your B of what they give you. We will have to do total distance on the AB, but then not the BC this year. Okay, not the BC this year because we're in 2020. 2020, they're making the test only 45 minutes instead of 3 hours and 15 minutes. Okay, so x e to the x squared dx. Okay, so this would be u sub. So du equals 2x dx. I like to solve for dx. It makes me more flexible on other problems. So this is du over 2x. The x's do cancel. If I had any x's left, say you had x to the third e to the x squared, I would still do the same thing, e to the u du over 2x. Okay, then these would cancel, and I would get x squared e to the u du, and I'd kind of be sad because I can't do it separately, but then I could back substitute, because this would be u e to the u du, and then maybe I could use parts. Okay, so this is a what if. This isn't a real question. What if? But that's how I like to review. Okay, so back to the real question, which would be 1/2 e to the u du. Antiderivative of e to the u is e to the u plus c. Don't forget your plus c. So e to the u is this, and that answer is answer choice A. There are no multiple choice questions on the 2020 test anymore. This is answered. Oops, wow, that was cool. Okay, answer choice B. Oh, I already said that. So this one turns out to be B. That one turns out to be A. But there's still good questions to practice. So multiple choice lets us rapidly review many topics. So it's still important, regardless if the 2020 test doesn't have multiple choice on it. The only reason they took off multiple choice is because since you're taking it at home, it's easier to catch plagiarism and cheating. If it's free response, if it's multiple choice, it'd basically be impossible. Okay, so a limit, remember for limits, you substitute the number in first. That's your first job. So this is sine of 0, cosine of 0 over 0. That's 0 times 1 over 0, which is 0 over 0. If you have 0 over 0, you can use L'Hopital. Now, if you don't have 0 over 0, you can't use L'Hopital. 0 over 5 is 0. 5 over 0 is, in a limit, it's usually infinity, negative infinity, or does not exist. Okay, so 0 over 0 is the only one that I can use L'Hopital's rule on, or, remember L'Hopital, I can do 0 over 0 or infinity over infinity. Okay, so back to this question. So I do need to use L'Hopital. Limit as x approaches 0. You're not doing the quotient rule. You're just taking the derivative of the top times the and then over the derivative of the bottom. Okay, so that's sine x times the derivative of cosine x is negative sine x, plus cosine x times the derivative of sine x, which is cosine x. And then you substitute the 0 back in. Okay, so substitute the 0 in. That's 0 times negative 0 plus cosine 0 times cosine 0, 1. That's 0 plus 1 over 1, which is 1, which is answer choice C. Except, oh, I have the AB answers out. That's funny. I was like, I really think that's the answer. Okay, that's funny. So that is the AB exam. So I have this thing that says answers to the AB and the BC exams, but it only has the AB. It doesn't have the BC. Okay, so hey puppies! Okay, let me pause for my howling puppies. Okay, I found the answers meantime, and my answers are right, so we're good so far. Okay, so next one is number 4. So let's see, number 4. Ooh, okay, very cool. Ratio test. Ratio test they have not removed from the test, from the 2020 test. Let's see. N factorial e to the n. It's already in this format. That's nice. If it wasn't in this format, this is the format we need to change it into in order to do the ratio test. If the ratio test is applied to the series, which of the following inequalities results, implying that the interval converges? Okay, well, that's interesting. So they're definitely forcing you to use this method. So the ratio test is limit as n approaches infinity. It's technically it is the absolute value. So it's e to the n plus 1 over n plus 1 factorial. Remember, you're substituting in an n plus 1. And then you're dividing it by the original, n factorial. Okay, and then this is going to be rho. Okay, so limit as n approaches infinity. That's e to the n times e to the 1 over n plus 1 factorial times n factorial over e to the n. Okay, and remember, even though this is multiple choice, your format is going to be in free response format, so you're definitely going to want to show all of the details of your work. Okay, so e to the 1 times n factorial. You expand the larger one, so n plus 1 is larger than n. It's like, say you have 10 factorial, and up here you have 9 factorial. So if you expand the 10 factorial to be 10 times 9 times 8 times 7 times ... You can go all the way to 1. You could write this as 10 times 9 factorial. You could write it 10 times 9 times 8 factorial, 10 times 9 times 8 times 7 times 6 times 5 factorial. You just keep lowering by 1 until you want to stop. Okay, so this is choices that you have. So for ours, n plus 1, minus 1 would just be n. And then minus 1 would be n minus 1, and then minus 1 would be n minus 2. But I like that it's going to cancel with the numerator, so we're going to stop at n factorial. And then those cancel. Everything's positive, so I don't really need the bars anymore. And then limit as n approaches infinity. E right now is just a plain number, and then I'm getting infinity plus 1 in the denominator. Okay, so basically, this is, remember if you're doing a limit, this is donuts on the top, okay? So think donuts at the top. So I have E donuts, 2.7 donuts. I have 2.7 donuts, and people are at the bottom. So I have 2.7 donuts and 1 million people. So I basically almost get no donuts per person. So this limit is 0. Now, this 0 is less than 1. So that does converge. Okay, so converges by, we want to practice, so by ratio test. So you want to be thinking of these as what if it was a part of a free response question. So what if this was part A, free response question part A. Okay, now it is multiple choice though, so we do need to match it. So let's see. They said limit n approaches infinity. So I have that part. I have an E here and an n plus 1 in the denominator. So that's probably the answer they have. And it's always less than 1. So it looks like D. Okay, so the answer here would be D. And that is correct according to Mr. Calculus. Mr. Calculus is an awesome teacher who used to teach at Diamond Bar High School. And he's amazing. Anyway, so he has solutions as well. I just happened to find on his website the answers. I'm not looking at his solutions, but it's nice to have the answers because you guys know I make careless mistakes all the time. Okay, not all the time, but I do count on you guys to catch my mistakes for me. E to the, looks like a 5t. And then I'm going from t equals 0 to t equals pi. So I don't have to graph it for arc length. Now this is length of the curve. This is one of the topics that has been, at this moment, removed from the 2020 test for BC. The only thing that's on it is AB plus some series topics. Ratio test, let's see, there's 5. Ratio test, Taylor series, alternating series, geometric, and harmonic. Those are the only things that are listed past AB. So we need to go back and practice some AB. But still, you already did this, so we might as well do it. Okay, so let's see. So there's a formula for arc length, right? So there's multiple formulas for arc length. They all have to do with square roots. Depends if you're in parametric or if you're in polar. Our main one is this one. Okay, so this is our main arc length. It is a plus. The plus comes. Okay, this plus, maybe I better erase that little negative sign. The plus is from Pythagorean theorem. So you want to remember that it is a plus. Okay, another one is with dt's. The dt one is dy dt squared. Usually I put the x first. So let me erase that. So it's dx dt squared plus dy dt squared. Okay. Now, if you haven't done these questions, you got to make sure you do them before you listen to my explanations, or you're not going to learn anything. Okay, and then polar, just for your future knowledge, not on your AP test, dr d theta, and that's it. Or there's one more, 1 plus g prime of y. Oops, this one's a d theta. Okay, and then this one's dy. So those are all your choices, just so you could remember. But we're doing this, which looks like parametric. So not on this year's test, but it will be on a test in the future that you'll have in college maybe, and other years of AB. Okay, so this would be dx dt. I use the product rule, and then dy dt. Derivative of e is e to the u times basically the derivative of the numerator. And then you're going to substitute that in to this formula. So I'm going to use the middle one, because I have parametric. And that's the square root of dx dt, which is 3t squared cosine of t cubed squared plus 5e to the 5t squared, and then dt from 0 to pi, which is the information they gave us in the beginning. Okay, and it is a t, so we're good, but you want to definitely pay attention to the letters, because if they had said x, then we would have had to convert it into t. Okay, so let's see. Their answer, 9 t to the 4th. Okay, so this is 9t to the 4th cosine squared of t cubed plus 25e, multiply the exponents, e to the 10t dt square root. This is not one that you could do by hand, so they would have to leave it like this, or have one that is possible to do by hand if this is on the free response part. Okay, so that's it. Let's see, number 5 on Mr. Let's see, yep, C, that's what he put too. Okay, so let's see. Number 6 is an AB topic. Wow, let's put AB topic. Is this our first AB topic? Let's check. That's BC topic. This is BC. This is BC. This is AB. 3 is AB. 2 is AB. This is BC. Cool. Okay. Hey, AB was a long time ago, so we got to review all the AB as well. Okay, so AB topic. AB topic, see what you think it looks like. But you guys already tried it, so you're not identifying at this point. So this is if x does not equal 2, and 1 if x does equal 2. Okay, piecewise. Which of the following is true about the graph? Limit, continuous, differentiable. The thing is I think I can graph this one. So I'm going to do it the algebraic way over here, which is the usual way I would do it. But I don't know, all of a sudden, I have a graphical feeling. Okay, so let me look at the graphical way. I can reduce that top of the piecewise. I could factor it. If I factor it, okay, so let's do a wiggle. If I factor it, those cancel, and I get x, I'm going to write y equals. So y equals x plus 2 when x does not equal 2, and y equals 1 when x equals 2. So let's see. X plus 2 would be 2. Let me change to graph paper so you guys can see this better. Okay. So let me go back over here. Okay, so let me go to graph paper so you could see it a little better. Let's see. 2 is the y-intercept, right? So y-intercept is 0, 2, m equals 1. So 1, 1, 1, 1, 1, back, 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 rise over run, up 1, right 1, up 1, right 1. So this is my line, but I want x to not be 2. So I'm going to go over to 2 here. I'm going to say I don't want to pick 2. I do want all these. I do want all these. And then at specifically 2, it tells me only go up to 1. That's a beautiful picture. Okay, so how exciting. So we can answer just based on this, but what if the equations were so complicated that I couldn't graph it? So I want to have another choice. Okay, so is there a limit? Okay, so limits, it's been a while since you thought about limits, but specifically these kind of limits. So for there to be a limit, I'm going to draw this in blue, highlighted in blue. So where I'm headed on this side has to equal where I'm headed on this side. So usually I use the blue with my right hand and the yellow with my left hand. Do they go to the same place? I call it, is Mr. Knox home? Okay, or Mr. Knox doesn't have to be home, but it's his classroom, not his real home. This looks like it's up at, what, 4? Yeah. Okay, so to find a limit, you and your friend are going to Mr. Knox's classroom, okay? So blue, that's you. And then somebody else is yellow. And you and your friend, you're meeting at Mr. Knox's classroom. Now, did you end up meeting at Mr. Knox's classroom? I would say yes. Okay, so he's in room 4. So it looks like you're headed to Mr. Knox's classroom. There you get a 4. It's a y value. Remember, the answer to a limit is a y value. Mr. Knox doesn't have to be home. Okay, so just because there's an empty circle in his room, you and your friend still do meet. If you had a situation where one person is going to this point, and then another person is going over here, okay, Mr. Knox is in the closed circle, but that doesn't matter because you and your friend won't meet up. So limits are about you and your friend meeting up. Continuous means you and your friend are headed to the same spot and Mr. Knox is there. Okay, I use Mr. Knox because his classroom is right next to mine. Okay, so anyway, there we go. Okay, so sounds good. So the limit is there, so it's 4, so it does exist. Is it continuous? I would say it's not continuous. Okay, it's not continuous because I had to lift my pencil. There's an official reason, though. The reason is the limit as x approaches 2 of f of x does not equal the f value at 2. Okay, the f value at 2 is 1, and the limit is 4. So that's just visually from the picture. So it's not continuous. So 2 is false. 1 is true. And 3, is it differentiable? Okay, so to be differentiable, there has to be, it has to be continuous. So usually I call differentiable like rule number 4. Okay, this one is 1, 2, and 3, so those are going to kind of mess up our rules. But it's like rule number 4, and the first 3 rules is that it has to be, have all the first 3 continuity rules. So I would say this is no, and that's because continuity is required for differentiability. Okay, so that'd be a no. So the answer is only 1. Okay, but let me show you the algebraic way. And you can see where if you didn't graph it or if you didn't remember your exact rules for differentiability, you might have made a mistake. So let me go back up. You can pause if you need to go back to this. Okay, but let me, I'm going to zoom up or go back up and talk about the algebraic way. Okay, so the algebraic way, usually I call it Roman numeral steps. Okay, but I'm going to call these 1 because this is Roman numeraled already, so I don't want to mess you up in the problem. But f of a exists. This is this 3-step process. Okay, so this is the 3-step process for continuity. Okay, so the limit as x approaches a from the left side has to equal the limit as x approaches a from the right side and the left side. The right side is the positive one, so this one's called the right side. And then this yellow one is called the left side. Okay, that actually corresponds with the graph that I drew in the other one, but you don't have to draw a graph to do these. And then the last one is that f of a has to equal the limit as x approaches a of f of x. And this limit right here is basically the answer that you get in step 2 if those limits are equal. So these 3 are for continuity. Okay, 2 only is the limit. And then 4 is differentiability. So it needs to pass, this is for differentiability. So for differentiability, it's not just 4, it's 4 all the way up, back through 1. So you have to pass tests 1 through 3, and the derivative on the left side of A has to equal the derivative on the right side of A. Okay, so let's take a look at the equation they gave us. Okay, so f of A is my potential spot, is 2, where the problem might be. Now, according to the equation, so if I zoom back into where the equation is, according to the equation, that is the bottom one. It says x equals 2, the y value is 1. So that's the answer here. So the answer is 1. That's where is the closed dot, basically. Okay, rule number 2 says you need to find the limit as x approaches 2 from the left side. Okay, now from the left side would be not 2. That would be like 1.9999999999999. Okay, so I'm going to use the top equation. So I'm going to use x squared minus 4 over x minus 2. Now let's say you didn't notice that it factored. You could do 0 over 0, and then you could use L'Hopital's rule, 2x over 1, and then take the limit again. X approaches 2 from the minus side. You substitute the 2 in, and you get 4. The minus sign doesn't matter when you're substituting the values in. So you do get 4. Limit as x approaches 2 from the positive side, x squared minus 4 over x minus 2. You could also use L'Hopital's rule, but let's say you got 0 over 0 when you substituted this in to both of these. Let's say you factored instead. Okay, so say you did this instead, or L'Hopital. Both ways would work. Okay, cancel, cancel. It's kind of nice. People must be walking by my house. So the puppies are barking at them so that they'll keep going and keep walking. Of course, they're going to keep walking. But my puppies seem to think that it's because of them. Hey, puppies. Hi, puppies. Come do math instead. Come do math instead. Okay, so then this is 2 plus 2. And that's 4. So the limit is 4. So step 2, limit as x approaches 2 of f of x equals 4. That's because these two values matched. Let me highlight those for you. These two values matched. If they match, there's a limit. If they don't match, there's not a limit. So this is number 1. Okay, so number 1 is true in our list, not in the limits in this list here. Okay, so 3, for continuity, I need the limit from step 2. Usually I'll call it step 1 equals step 2, but I do it in Roman numerals, but I don't want to mess this up because there's already Roman numerals in this problem. So we have the limit has to equal the function value from step 1. So step 1 said the answer was 1, and step 2 said the answer was 4, so that means it's not continuous. Now, it's actually called a removable discontinuity. Okay, this is called a removable discontinuity. Okay, and that's because it passed test 2. Okay, so if there is a limit as x approaches a of f of x, and it equals a number, but it's not continuous, then it's called removable. Okay, so removable versus non-removable. Okay, so it's called a removable discontinuity. Okay, so that means you have to fail test 1 or 3 and pass test 2. I told you I'm used to using Roman numerals, so it's very weird for me not to use Roman numerals. So those Roman numerals are my are these blue highlights right here. 3, 2, and 1, because those are my continuity rules. Okay, so let's look at rule 4. So rule 4 is for differentiable. Okay, so for differentiable, you must pass 1 through 3, and I already failed. Okay, failed number 3. So it is not differentiable. Okay, but what if this question had just said if it's differentiable? Look how easily we could have been trapped. So say I go to my simplified version of this problem, which was what? X plus 2 if x's don't equal 2, and 1 if x is equals 2. Okay, so say it was like this, or say you had this. X plus 2 for x is greater than 2, x plus 2 for x is less than 2, and 1 for x is equal to 2, which is kind of the same thing as this. So you could imagine if they asked if it was differentiable, you would say, well, let me take the derivative. So that's 1 and 1. 1 for x is greater than 2. 1 for x is less than 2. Okay, and then you would drop the equal to 2 because it doesn't make sense to have a slope like at one point if it's not connected to anything else. And it appears that they're equal. So the slope from the right side of 2, okay, this is the right side. So the slope from the right side of 2 is 1. And the slope from the left side of 2, okay, that's this one. Okay, that is 1. So you could see where somebody definitely would say, hey, it's differentiable. The slopes do match. But it's not continuous. Okay, that's why one of my old students used to said, well, why are you calling it differentiable separately? Why don't you call it step 4? Because step 4 implies you have to have steps 1, 2, and 3 true. So I thought that was very helpful. So that was a long time ago. That was like my first year teaching AP back in 1994, 1995. Okay, so it's not continuous, so it's not differentiable. Okay, so we didn't even have to find the slopes. Differentiable. Okay, so it's not differentiable. Okay, even though the slopes are the same. Now, if the slopes were the same and it had passed rule 3, then it would have been a continuous and differentiable. So how would I have changed it? I would have just made, in step 1, I guess if step 1, I had said, hey, Mr. Knox is home. So at f of 2, if I made that value 4, that means we would have passed test 3. And that means we would have passed test 4, and so it would have been continuous and differentiable, and there would have been a limit. Okay, I'm at 31 minutes, so I think I'm going to stop. What number am I on? Number 6. Oh, but I do want to put what answer I got. So let's see. I have to go back and put my password in and see what the question is. Okay, so 6 has a limit. So 1 is yes. 2, it's continuous. No, it failed test 3. And 4, is it differentiable? No. I didn't mean check mark. No, it's not differentiable because it's not continuous. Okay, so it's only 1, and only 1 would be A. And let's check with Mr. Calculus. Is that what he got too? That is. That is what he got. And that's also what we got on the right side when we did it the graphical way. It's good to be flexible, so it's good to have both ways. Okay, see you soon. Question number 7.